Hey guys, so in this video, we're going to be talking about two-way tables and their probability. You may have seen or worked with two-way tables before, but now we're going to kind of build upon it. And if you've never seen a two-way table, don't worry, we're going to go through how to deal with that as well. So the first thing is we're going to go through this exploration where we're going to create a two-way table from a Venn diagram. So a Venn diagram, if you aren't already aware, it's a visual of a bunch of data. So in this one, we have it surveyed 80 students. They tell us that, right? So we have 80 students, and it's broken down. We have 25 students who play an instrument, 30 who speak a foreign language, 16 do both, and then we have this 9 on the outside. The 9 means they do neither of them. They don't play an instrument, and they don't speak a foreign language. So we can use this to help fill in this table over here. First off, I like to start with a total if I know it. So I know that there were 80 total students. So that's the total. And the reason I say that is because we have the total columns and we have the total rows. But total altogether is that bottom right-hand corner. So as we go through this, we're going to use this data. So I'm going to start with this 9. 9 do nothing. They do not play an instrument and they do not speak a foreign language. So I can fill that in this column right here. It's under do not play and do not speak. Okay. Those who play an instrument but do not speak a foreign language would be the 25. They're in their own little part of the bubble over here. So they do play an instrument, but they do not speak a foreign language. That's 25 right there. Then we have those who speak a foreign language, but do not play an instrument. So there's 30 of them over here. And we have 16 who do both. They play an instrument and they speak a foreign language. So we're able to fill in our whole two-way table. And the last thing we can do is just add up our totals, right? So 16 plus 30, that's 46 over here. 25 plus 9, that is 34. And then we can do our columns. 16 plus 25 is 41. 30 plus 9 is 39. Right? We just add those together. And what should happen is if I add up the totals, 41 and 39, that's 80. Perfect. 46 plus 34, that's 80. Perfect. It equals the total amount of students that we surveyed. And then from there, you can obviously answer the questions that are asked, right? We can answer how many students play an instrument. Well, that would be obviously under the play an instrument total. It would be 41. How many students speak a foreign language would be under our speak a foreign language total, 46. How many do both? We know that, right? That's 16. How many do not either? That was our 9. And then we have obviously other parts of this that we can come up with as we go through it. From there, we could find probabilities, and that's what we're going to be getting into. How do we then take those components and find probabilities of that? And basically, it's just taking the value over the total amount. So out of the total of 80 students. So if 9 did not speak a foreign language or play an instrument, it'd be 9 out of 80, right? We had the 16 of them who did both. It'd be 16 out of 80. Right? So we would be able to take each component, take it out of the total, and find its probability. We could then get more specific and look at totals of all students who speak a foreign language or all students who play an instrument and go based off of their totals as well. It just depends on the criteria that we're going to ask of you. Okay. So first off, we need to know about some names and some parts. So I'm going to move myself over here for right now. Knowing some terminology is important. So a two-way table is just a way of collecting data and displaying it. We have what are called joint frequencies and marginal frequencies. Joints are the interior part, okay? They are what's joined together to make our totals, if you want to kind of think of it that way. So it's each entry on the interior of our table. Once we start adding in those totals, notice that this first table doesn't have the totals. The second one does. That's where our marginals frequencies come into play. They are now on the margins, on the outsides, okay? And they are always going to be the totals of the rows and the columns, okay? So that's really important that you know the marginals are the totals of each row and column, and they sit on the outside. They sit on the margin. So like if I was to say your margin of your paper, right? We know the margins are on the edges. When you have to describe your frequencies, okay, I'm going to move myself over here for a moment. When you describe your marginal frequencies, you basically tell what they mean, talk about each component. So in this bottom one, which talks obviously about males and females and their cars they drive, I can just get that from looking at the data. I can tell based off the marginal frequencies, there were 60 males that were surveyed, 180 females were surveyed. Those were the totals in the margins of the rows. I know that 156 people drive SUVs, and I know 84 people drive sports cars because those were the totals in those columns, and that a total of 240 people were surveyed. So whenever they ask you to describe the marginal frequencies, it's just putting into words what happened, what were you surveying, right? And just talking about those totals. You can get in more specific if you really wanted to and talk about the joint frequencies that, 21 males drive sports SUVs, 135 females. But if they're just asking for marginal, you just talk about the totals and what they represent. Okay. Now, when we talk about making a two-way table, they're going to give you some of the data, not all of it. Okay. And we're going to be doing a bunch of these in class and then breaking them apart into the different types of probabilities. But you do want to be aware of what they tell you. And basically, it's just a matter of adding and subtracting to fill in the missing pieces. So I'm going to rewrite over what is written here so we can, let me choose a bright color so you can see what I mean. It's already filled in, but that's okay. So it says in another survey, we have 106 juniors and 114 seniors. So I already know totals of those. So that's where this all came from, right? Here's my 114. Here's the 106. They told me that in the beginning. It says of those, 42 juniors and 77 seniors plan on attending. Okay. So they're attending, I believe, a sports game. So 42 juniors, that one here, they are attending. 77 seniors are attending. And that's all they gave us in the storyline. We had to then figure out everything else. So obviously we have things to create. We needed to know that there was juniors and seniors, whether you label it as classes or you just name them, that's up to you. We know that they're attending. That was the only thing they tell us, which then tells me I need to come up with, well, what's the other word? They're either attending or they're not attending. So that's where this one comes from. I had to fill in that based off of kind of getting an idea of what they were talking about. And then to find all the missing pieces was just a matter of adding or subtracting. If I know there was 106 juniors and 42 are attending, you subtract them to find they're not attending. And that's what it tells you up here. You would do the same thing with the seniors. 77 out of the 114 are attending. So you subtract them. And that's how many are not attending. And then you could simply add together to get your totals on your bottom, right? So again, it's simple, just adding or subtracting to find all the missing pieces of your table. Really, the hardest thing is figuring out, well, what are you labeling all your parts of your tables if they don't tell you, each component, right? So like I said, in this case, they only said they were attending. Can't just have a single column there. I had to figure out that they were also not attending. Right? So again, we're going to go through and work together in class on creating a couple more two-way tables and talking about their marginal frequencies as well. Now, the other thing is to come up with their frequencies. The marginal frequency is kind of the probability that we're looking at, and it's a ratio You can write it as a fraction, you can write it as a decimal, you can write it as a percentage. We are talking about the probability. So the joint and marginal frequencies, that is based off of your full total. So how many total people you were surveying. So like in that junior and senior class, there was 220 total students there. So the joint and the relative is going to be out of 220. The conditional is when I put a condition on it, meaning only look at a specific row or a specific column. So I might say only look at the juniors or only look at those attending the game. Okay, that's when I'm throwing a condition on it. I'm not telling you anymore to look at the whole thing. I'm telling you look at something specific. Okay, and you can see that here. So in this example, we have our joint frequencies on the inside. There's the 220s, right? That is your totals. And I even wrote in where the marginal ones came from. And then they divided, like I said, you can leave it in decimal form, fraction form, or percentage. It is your personal preference. Okay, so even here you can see they have the percentage there. So again, your own personal preference. I tend to change things into percentages just because that's how I deal with probability. But if you want to keep it as a fraction, go for it. Nothing wrong with that. Okay, so again, these are your joint and your marginal. Joint is the interior, marginal is your exterior, and they're all out of the total amount, the total amount, right? So the 220. And then you'll always see that the corner will always be 1 if it's out of the total amount. Once we start looking at a condition, it's a little bit different. Now the condition says we're looking at each row. So we were looking at grade levels now, right? The rows are juniors and seniors. So I know from the previous problems, I had 106 juniors, I had 114 seniors. So I only do the specific rows total now. So 42 attended out of the 106 juniors. 64 did not attend out of the 106. Okay, same thing with my seniors. 77 out of the 114 attended, 37 out of the 114 did not attend. So again, completely up to you. You can make it as a fraction, leave it. You can make it a decimal, or you can make it a percentage like you see out here. Again, it's your own personal preference, but just know the difference between this one and the previous one, right? So our previous one, that is joint and marginal, are out of the total. Conditional is when I put a condition on it. I'm telling you to only look at a specific row or a specific column to figure it out. So in this case, it was looking at the classes as opposed to the attendance. And that's why our denominators changed to go with the rows total. Okay. And again, we'll go through, we'll do some practice, and we'll find those frequencies as well. And then the last thing is we can come up with, if they've already given us some frequencies, just determining the probability based off of that, which again just happens to deal with looking at the table and breaking down the table into different components of it. Okay, we'll be going through this in class. And if you need another video going through all those examples, I will make that one later on.